All right, in this video, we're going to do quadratic trig equations with double angle identities. We'll do two examples. Notice they both involve cosine of 2 theta if you just scan. We're finding angles on the intervals 0 to 2 pi that satisfy the equation below when we're rounding to thousandths. Okay, so the first thing to note in this equation, as crazy as it looks, is we really can't do much until we replace this cosine of 2 theta here with a identity. Now, if you look at the problem, you'll note that sine of theta is involved, so you'll want the identity that involves sine of theta. And to do that, I'm assuming you're coming to this knowing the identities are happening somewhere. I'm just going to write in here that this is 1 minus 2 sine squared of theta. So that's what I see there. Now, let's distribute it and then rewrite the rest of this just involving s's here. So I'm going to rewrite this as -3, 1 minus 2 sine. I'm just going to write as s for now because it's an abbreviation here. Plus 8 equals -8s plus 3. Okay, we distribute, and when we do that, we get -3 plus 6s squared minus 15s plus 8 equals -8s plus 3. Let's combine some terms for ourselves. So this here I see can combine with that to make a 5. And so let's see, I get 6s squared minus 15s plus 5 equals -8s plus 3. And last thing to do is add 8s to both sides. So there's a lot of, in this problem, there's a lot of algebra that has to be done first. I'm going to minus 3 from both sides. Okay, so then once we get that, then we can get to the, get to the algebra, to the trig rather. So this is 6s squared. This becomes a -7s, and this becomes a plus 2 equals 0. Okay, let me just take a second to double check that. I think that's right. Looks good. So now we factor that. So I'm going to move up here. So 6s squared minus 7s plus 2 with a little trial and error, you can see that factors to 3s minus 2. Right, so 3s minus 2 times 2s minus 1. Okay, you can double check that, but I think that is good. So that tells us that s here equals 2/3, or s equals 1/2. Remember, s stood for sine, so this really means sine of theta is equal to 2/3, or sine of theta equals 1/2. Let's do the sine of theta equals 2/3 first. Let's draw our unit circle. Okay, sine of an angle is the y-coordinate on the unit circle. We want to know where the y-coordinate is equal to 2/3. That would be somewhere here. Right, there's the line y equals 2/3. So one of the angles is this angle here. Okay, we'll call that θ1. The second angle is this one. That's kind of a mirror image of it. Okay, notice that's 180 degrees minus θ1. So our second angle here, I'll just note right here, the second angle is 180 degrees minus θ1. Okay, because this over here is equal to θ1. And the angle we're looking for is just that angle shy of 180 degrees. All right, so that means that θ1 is equal to sine inverse 2/3. We use our calculator. Sine inverse of 2/3. I need to be in radian mode. Let's just go double check my mode. So I'm in degree mode now. I need to turn to radian mode. Okay, so I do sine inverse of 2/3. That's 0.730 if we look at the directions carefully, right? It said around to 1,000, so 0.730, and that means that theta 2 is equal to 1. I said 180 degrees. I really meant pi, right? So 180 degrees is pi minus 0.730. Okay, so we're going to do pi minus our answer here to get 2.412. Okay, there's our first two answers. The second two answers here come from sine of theta equals a half. So that means that theta 3 is sine inverse of a half, and that should strike you as one that can be done without a calculator. The angle whose sine is 1/2 is pi over 6. And so, you can imagine me drawing a similar unit circle up there. It would actually look identical. The angle would be pi over 6, and then therefore our fourth answer would be pi minus that. Okay, so pi minus that will give you, so that's 6 pi over 6 minus 1 pi over 6 is 5 pi over 6. Okay, so there are our first four answers, or our answers to the first problem. Let's do this one here and finish this off. So I see a cosine of 2 theta here. Because this problem has cosines everywhere, I need to use the identity that cosine of 2 theta is equal to 2 cosine squared theta minus 1. So then, again, using c instead of cosine, I get 2c minus 6 equals negative 3, 2c squared minus 1 minus 9c minus 2. We distribute, we get negative 6c squared plus 3 minus 9c minus 2. Let's see if we can do this as efficiently as possible. I'm going to minus 2c from both sides. I'm going to add 6 to both sides. So this becomes 0 equals negative 6c squared. This gives you 9 minus 2 is a 7. So it's a plus 7. And then you've got negative 9c, and negative 2c is negative 11c. Okay. Let's multiply through everything by negative 1 so that I have a positive leading coefficient. So multiplying through by negative 1 gives you positive 6c squared plus 11c minus 7. Take some time to try to factor this. I think you end up getting 3c plus 7 and 2c minus 1. Let's just take a second and double check that. That looks right. Good, so this tells us that c is equal to negative 7/3, and this tells us that c is equal to a half. So we deal with this one first. Remember, that's cosine. So cosine of theta equals negative 7/3. Notice that's negative 2 1/3, right? Okay, but there's that cannot produce any answers because cosine is the x-coordinate on the unit circle. Cosine of theta can only be between negative 1 and 1. So, you can kind of hash that. It's not going to produce any answers. On the other hand, this one here is cosine of theta is equal to 1/2. This can be done without a calculator, but let me just note cosine of theta is the x-coordinate on a unit circle. Right, so the x-coordinate equals a half. That happens, I'm just going to draw a vertical line, that x equals a half. That's going to happen at this angle here. Okay, that angle there is theta. That's one of our answers. So cos inverse is going to give us that one. The other one is here. Okay, the other one is there. So in order to do that, what we can do is, once we get theta 1, then you're just going to want to do, so this angle here is the same in absolute value as theta 1. We're going to do 360 degrees minus theta 1, or 2 pi minus theta 1. Okay, so theta 2 is going to be 2 pi minus theta 1. Okay, so again, though, we don't need a calculator for this one. Theta, our first answer really is cosine inverse of 1/2. Okay, the angle whose cosine is 1/2 is pi over 3. And that tells us that our second answer is 2 pi minus pi over 3. Okay, and 2 pi is the same as 6 pi over 3. So 6 pi over 3 minus pi over 3 is 5 pi over 3. So the key takeaway, even though there's a lot of math there, the key takeaway was the identities that we used at the beginning, the well-chosen identities. Notice I focused on the algebra first, the factoring, and then I dealt with the trigonometry once I had that done.